Hey, how's it going, Pre-Calc people? All right, video number 3 in the lesson 4445 scenario. Today's video is concentrating strictly on tangent. So not only am I going to show you how tangent comes about, how you draw it, we're going to go right into how do you draw it without, because I'm going to use the unit circle one more time, make an XY chart, graph it, and we're going to go right into how do you graph it without all that stuff once we see the weird quirks that tangent has involved. Because you already have a lot of that stuff, under control or have had it presented to you in the sine and cosine graphing. So this will just kind of blend right into that. But there are some definite differences with tangent. So anyway, you'll notice the unit circle here that I have has a few more points than I did sine and cosine with. Sine and cosine, I just used the big 4/5 points, 1, 0, 0, 1, negative 1, 0, 0, negative 1, and back to the beginning. You'll notice that I've added the middle points of each quadrant. Most of you would probably say, oh, the 45-degree points. That's all fine and dandy if we're doing degrees, but we have to talk radians. So I'm talking pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And the nice part about those points is they always use the point square root of 2 over 2, square root of 2 over 2. So, and then the next little reminder as we get into business, or down to business, please remember on the unit circle, tangent is the y-coordinate divided by the x, which makes it more challenging because you actually have to divide. Sine and cosine, you just look at coordinates. If you're cosine, you just look at the x, oh, there it is, that's it. Sine, y-coordinate. This, you actually have to do a division. So I have selected the easiest points we can divide. Now, over here, we're going to start talking about this. Now, you'll notice I put the key 5 points that I did for sine and cosine, but I'm going to incorporate the other ones. That's why I've left some spaces here, 1, 2, 3, 4, to incorporate those 4. But I want to talk about the big 5 points first. So, starting at 0 radians, remember we're doing y-coordinate divided by x. So at 0 degrees, or 0 radians, y divided by x is 0 divided by 1. 0 divided by 1 is 0. So 0, 0 will be on our graph in a few minutes. Now here's the immediate weirdness of tangent. If you go to pi over 2, and do y divided by x. See up there, it's 0, 1. So y divided by x is 1 divided by 0. Can't divide by 0. It's undefined. And that's the issue. So there won't be points there. There'll be, you've heard this word in class before, asymptote. There'll be a vertical asymptote at pi over 2. Continuing on to negative 1, 0 at pi. Y divided by x is 0 divided by negative 1. That's back to being 0. 3 pi over 2, 0, negative 1. That's the point. Y divided by x is negative 1 divided by 0. There's that divide by 0 again. Another undefined. And then when we go back to 2 pi, it's the same as we started at 0 radians. That's y divided by x is 0 divided by 1, back to 0. Now the weird thing is if I plot these points, first of all, there's only 3 actual plotted points, and they're all 0, and then 2 undefined locations. So we got 0, 0, pi 0, 2 pi 0, and pi over 2 is undefined, so we'll do this, and 3 pi over 2. Those are undefined areas, can't cross them. That won't happen. So this is why we need these extra points. This is why we need the pi over 4 in here, and the 3 pi over 4 here, and 5 pi over 4, and 7 pi over 4. And those places on the graph are going to fit in here, 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 and here. splits the middle. Now, you guys, the thing to immediately realize is if I go to those 4 locations, they're all some version of square root of 2 over 2. Some are negative, some are not, and so on. You got to understand, if you do y divided by x, where x and y are the same number, you're always going to get 1 or negative 1, because you're dividing 2 same numbers. Here, at pi over 4, you're dividing positive square root of 2 over 2's. That's going to be 1 right here. When you go over to 3 pi over 4, one of them's negative, so when you divide them, you get negative 1. When you go down to 5 pi over 4, they're both negative, so negative divided by negative is positive 1. And then 7 pi over 4, you're back to one of the 2 numbers being negative, so when you divide them, you get negative 1. Now, if I throw those into the mix, pi over 4 is up at 1. And I don't have these labeled, so I should do that. This is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, at 3 pi over 4, I'm at negative 1, so that's right there. At 5 pi over 4, I'm back to positive 1. And at 7 pi over 4, I'm back to negative 1. Now, we need to talk about just a little bit, like what happens here. I think it's kind of natural to see, well, this is going here to here. It does go up to positive infinity, and there's an explanation for that. This is where I so wish we were in class together so we could really, really talk about this. But I'll do my best here. I want you to imagine a point, and I'm only going to do this once and try to explain this once, but I want you to imagine a point really, really close to pi over 2, but not quite there yet. So in the first quadrant, really close to pi over 2. Now understand, pi over 2 from the origin is 0, 1, straight up 1. So I want you to imagine if I was right dead in front of it, like so close you couldn't even see it with the naked eye. Imagine that the x-coordinate would be something really small, like 0.0001. Now I'm going to put a fake little point right there. You might not even be able to see it on camera. But a little red dot, super close there. What if, I'm going to take that off here, what if that point was 0.0001, comma 0.999? Because it's barely to the right of the origin and way up right close to being 1, but we'll say 0.999. Now here's my point. If I asked you for the tangent at that location, right in front of that, pi over 2, if we did y divided by x, folks, 0.999, that's the y coordinate, divided by 0.001, 001, you get 9,990. Which indicates that if I was right close to this, I have to go up 9,000 plus almost to 10,000. And you guys, that's not even the smallest. You know, think about numbers like 0.0000001 and 0.9999999. You start dividing those and you start getting millions and billions and trillions and such. That's why this graph goes approaching this asymptote, this undefined area, and goes to infinity. So something like this. It can't cross that undefined spot because there's no tangent at pi over 2. It's divided by 0. It's undefined. And the same thing happens in the negative sense. And back up here. And through here. Now, something that's kind of hard to see here that we're going to discuss. That actually is two repeating patterns in there. In other words, I actually just graphed 2 periods of tangent. There is a repeating area. And if I were to show you this, I want you to consider this window right here. Oops. Okay, look at that. Okay? And it's a weird looking shape because it's partially going up to the undefined and partially swinging down. This side is an exact replica of that. So I technically didn't need all of that extra, but again, going into the problem, we don't know that. We just approach it like, hey, every other normal problem's been once around the unit circle, 0 to 2 pi, until we change the period by putting numbers in the equation. Well, now we find out that there's another reason that tangent is different. So I'm going to get rid of that part of the graph because technically I don't need it. And there is one period of the tangent graph, and it's a disconnected graph. Okay, you can't, sine and cosine, you can draw with your pen, never pick up your pencil because it's, doing that wave thing. This has undefined areas. You have to pick up your pen or pencil every time you draw it. So that's how I do what I call one period of tangent. Other teachers have different approaches. I like this one because I like starting at 0 and going forward. So some specifications here, and then I'm going to pause this. And we're going to get down to business. Now, one thing that's important to note, there's no amplitude. An amplitude is kind of like a maximum point you reach. These don't go to a maximum point. They go up to infinity, so there's technically no amplitude. However, there's still going to be what's known as an A value, the number in front. So when I was graphing this, the number in front is technically 1. So if that was like 1 cosine, amplitude be 1. If that was 1 sine, amplitude be 1. Tangent, it's that passing through point. Okay? It doesn't stop there. It continues, but it is that transition. It goes right through that point on the way to infinity. And then the -1 on the other side, it passes through that on the way to negative infinity. So it's not called amplitude, but that A value still has a purpose. The period of this function is pi. So that's another thing that's different about tangent. It's not 2 pi under standard conditions, it's only pi. So I am pretty much going to erase all this stuff. I'm going to pause and erase, and then we're going to draw a few graphs taking the shortcuts that we've learned through sine and cosine. I want to remind you of a couple of things. That means tangent starts at 0, 0. It goes through what used to be called the amplitude, but it's a pass-through on the way to infinity. Exactly halfway between the beginning and the end of the period is the undefined location, because that represents this point up here, which is 1 divided by 0, undefined. And then it ends at 0 and has the -1 in the middle passing down to negative infinity. So keep that, you can put that on your notebook. You can keep it there while we start to do a couple of other things. So going to pause, erase, reorganize. Okay, so a little reorganized here now. So over here to the far left, we got everything summarized. If we now call this y equals a tangent bx, kind of like we called the other ones a sine or cosine bx, a is not the amplitude anymore. We say that the graph passes at a. And I'll cover that in the examples. Now the period part, it's pi divided by b now, because pi is normal for tangent, not 2 pi. So we have to be careful. So here we go. Got the first example right here. Y equals tangent 2x. Didn't get too fancy. Just put a 2 right there. So there is an understood 1 in front of the a, or in front of the tangent for the a value. So I'll put a 1 in the old amplitude position, and then we'll calculate this. Now, this being b, the period is pi divided by b. So pi divided by 2. Simple as that. There's the period. So as I go to draw this graph, it'll end at pi. Now, the a value means up 1, down 1. Not amplitude, but we need those numbers. And now, just like before, this is going to be no different. Once I identify where the period is, we're going to divide things up just like I taught you with sine or cosine. Meaning halfway, that's pi over 2. If you don't know that, excuse me. This would be the moment in class where somebody raises their hand and say, Mr. L, didn't you mean to put pi over 2 down there? Yep, I did. So that's pi over 2, sorry. Period's pi over 2, pi over 2. Halfway to that is pi over 4. Now, remember I told you, if you don't know those things, halfway to something is times half. So half of pi over 2, multiply straight across, 1 pi over 4. And then next, I need the halfway point of that, which will be pi over 8. Once again, if you don't know that, half of pi over 4, multiply straight across, 1 pi 8. I need that spot right there. Remember the first spot your counter, that numerator says 1 pi. So we're going to go 1 pi, 2 pi, 3 pi, 4 pi over 8. So 1 pi over 8, 2 pi over 8, 3 pi over 8. So there's the layout of the graph. Please remember, the graph starts at the origin, undefined in the middle, which is pi over 4. Ends in the middle. At pi over 8, it goes up to the 1. At 3 pi over 8, it goes down to the negative 1, which is roughly right there. And we go through here to positive infinity, back through here towards negative infinity. And there's what the graph looked like when I drew the original first tangent and stopped at just pi. So there you go. Next. This time, y equals 2 tangent 3x. One thing at a time, there's an a value of 2. That means I'll go up 2, down negative 2. Again, not amplitude. And I know I'm going to keep saying that, but tangent just doesn't have it. They'll be passing through at that point. Okay, period is pi over b. 3 is b. Pi over 3. So, period is pi over 3. That means wherever I put the last mark of my graph, that's pi over 3. Half of pi over 3 is pi over 6. And half of pi over 6 is pi over 12. Again, if you need those calculations, you do half of pi over 3 and multiply across. There's your 1 pi 6. And multiply half of pi over 6, 1 pi 12. Meaning, to get this last label correct, the numerator is 1 pi again. It is very common, but that doesn't have to be the numerator, but it's 1 pi. So again, it's 1 pi, 2 pi, 3 pi, 4 pi over 12. So 1 pi over 12, 2 pi over 12, 3 pi over 12. Okay, pause. 3 over 12 is 1/4. Pi over 4. And keep counting. The last one would have been, so this was 3 pi over 12, 4 pi over 12. 4 over 12 is a third. Pi over 3. We're good. And I should have done that over there when I did 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. 4 over 8 is a half. Didn't finish that one. Okay, here we go. Now, once I have all this stuff in, the rest is just follow the pattern. It starts at 0, 0. Undefined exactly halfway, which is pi over 6 this time. At pi over 12, it goes to 2 as the passing through. At pi over 4, it's down to negative 2. and it ends at 0 again. So it swings up on its way to positive infinity, swings back on its way to negative infinity. There you go. Last example that I plan on doing at this point, folks, unless I feel the need to throw in an extra little video explanation of something, but I'm hoping this will do the job. So for this one, I chose a couple of odd things. Number one, the a value is a third. Now that's just kind of a pain, but you know, sometimes that's how things come across, is they're not all easy. So again, what I typically do is I might put a 1 and a negative 1 and then do something like this. I just kind of like that feel. Now you don't have to do that if you want to say, I'm just putting 1/3 there, negative 1/3 there, and calling it good. I just kind of like that. Now we got a weird b value. B is 2/3. So I need to do pi divided by b. Pi divided by 2/3. We don't divide with fractions, we multiply reciprocals. So this is pi times 3/2. Please remember that can be thought of as over 1 in terms of organization. That's 3 pi over 2. That is our period for this particular graph. So down at the end of this graph, I'll put 3 pi over 2, and I'll begin my process. Now this one's a little bit more demanding, so I need half of 3 pi over 2, which is 3 pi over 4. Okay, so we kind of needed that. So this is 3 pi over 4. And then we need halfway to that. Halfway to 3 pi over 4 is 3 pi over 8. So that's this one. Okay, so we have a unique situation. People know, again, notice how last time I kept concentrating, hey, the numerator is 1 pi. 1 pi, 2 pi, 3 pi, 4 pi. Pi again, 1 pi, 2 pi, 3 pi, 4 pi. This one was over 8, this one was over 12. Folks, we got to count by 3. 3's, 3, 6, 9, 12. All over 8. Okay? Now this one's harder for me to count out loud. I'll stumble over my words, so I'm just going to kind of do the 3's first. So 3, 6, 9. 9 pi over 8. That doesn't need to be reduced. But you should check the other ones. So this was 3 pi over 8. This would have been 6 pi over 8. 6/8 is 3/4. 3, 6, 9 pi over 8. Okay, 12 pi over 8. Folks, 12 over 8 reduces to 3/2. We did count correctly. And then lastly, let's wrap up this graph. Start at 0. 1/3 on the first point, undefined on the middle point, negative 1/3 on this point, and back to 0 on this point. So this has more of a gradual curve to infinity, and this one goes back to negative infinity. All right, so you guys, there you have it. That is the end of section 4445. That is the wrapping up of graphing sine, cosine, and tangent with differing amplitudes, lesser talking tangent, and differing periods. If we were in class still, we'd be teaching what's called shifting. Shifting left and right, shifting up and down. But from a distance, that's difficult to teach and have everybody get it. So anyway, this wraps up this whole video segment for those lessons. Take care, you guys.